Carl Peterson with North Dakota State University. Today we've got with us Gary Orth and Joe Eisenhower. And what we're going to do is we're going to talk about an energy efficient house that we're in today. And we're also going to talk about how we can show that it is actually an energy efficient house, how we can measure that to show the provisions that went into this house to make it energy efficient. It looks like a typical house. You can't see the things that are behind the walls and behind the drywall and behind the paint. And that's what Gary's going to talk about. Just mention a few of the things that actually we can't see that make this such an efficient house. Gary?
One of the key ingredients that we use is in our basement, and what we do is we use ICF. It's an insulated concrete form. We'll look at that a little later. But another thing that we use is high performance heating equipment and cooling equipment, and then we also wrap the entire house really tight so that we're not pouring energy out, through our walls, our ceiling, recessed lights, outlets, those kind of things. And so in combination with that, attention to a lot of detail and high efficiency equipment, that's how we're getting the ratings and the energy efficiency that we are.
And the basic ideas with this house is we're putting heat into this house. It's just like a balloon. We fill up that balloon. We want to keep that in there as long as possible. Exactly. And that's what you're going to test for, Joe, with some of the equipment you have?
Two things that we'll test for today is we'll test for total home infiltration. So that'll give us our natural air change of the house, meaning basically how tight is this house constructed. And that's when we put a number to that. And that's what we're going to come up with today. And then the other thing that we're going to test for is actually the amount of air that's lost through the ductwork to the outside of the home. So in this house, it's not a big deal, but if you have, say, like a slab on grade, or if you have a lot of ducts that's above your ceiling or even below ground or that sort of thing, then you may be concerned about how much air we're actually conditioning outside of this thermal barrier of the house. And so in this case, we'll do both tests today. We'll test for, we'll depressurize the house, get into a negative 50 pascals, and that'll give us our tightness. And we can put a number to that compared to what we have for square footage and volume of the house, and that'll give us our number for that. And then of course we'll do the duct blasting.
And when you're talking about tightness, that air sealing, that tightness, those numbers, that means dollars going in essence out the door if they're not sealed up nice and tight to those areas for the homeowner, correct?
Right.
Great.
And one of the other things we have to our advantage too these days, and especially today because we probably have about a 25-degree temperature difference between inside and outside, is that we have a FLIR B50 camera that we're actually going to use. So when we put the depressurization on the house, we're actually trying to get as much air to come in anywhere we can. And if we do have any issues, we can actually look through our infrared camera and we can see if we have any infiltration or any spots that we need to look at anywhere on this house. And so we'll look mostly at the ceiling, and we'll look at the exterior walls around the windows and doors and electrical outlets. Any penetrations that we might have from inside the house to the outside is really what we want to focus on here. So definitely a great tool to have when you're looking at energy rating on a house.